So, in this next exercise, we must find the minimum and maximum values of this function h on this interval and then on this interval. But first, looking at this function, we can see that it's not that nice of a function. Precisely, it's not defined at x equals 5/3. So x can be 5/3, and we can see that 5/3 is inside this first interval, so we can't use our method here, so we can do this exercise. But 5/3 is greater than 1, so it's outside of this interval, so we are fine, we can use our method. To calculate the minimum and maximum, we must first calculate the value of h at the endpoints of the interval. So h of -3 will be 9/14, which is -9/14, and h of 1 will be 1/2 or -1/2. But since we will have to compare it with this value, we can write it as -7/14. Next, we must find the critical values of h which lie inside this interval. To do that, we must first calculate h prime of x. H is a fraction function, so the denominator will be 3x minus 5 squared, and the numerator will be 2x times 3x minus 5 minus x squared times 3. Now we must find out where h prime is 0, but since h prime is a fraction, we must only find where the numerator will be 0. To do that, we must solve the equation 2x times 3x minus 5 minus 3x squared equals 0. Simplifying this, we get 3x squared minus 10x equals 0. Factoring out x, we get x times 3x minus 10 equals 0. And now you can see that our two solutions will be x equals 0 and x equals 10/3. Now checking whether these are inside our interval, 0 is obviously inside our interval, -3, 1. However, 10/3 is greater than 3, which is greater than 1, so it is not in our interval. So we must find the value of the function at one additional point, which will be 0. So h of 0, luckily is easy to calculate, will be 0. And now we have 3 values here, which we must compare. 9/14, -9/14, -7/14, and 0. And we can clearly see that the smallest of these will be -9/14, so that will be the minimum of this function on this interval, and the greatest of these is 0, so that will be our maximum on this interval.